today's video, we are going to create experiment 7 on we're going to create the experiment 7 inner peak control inner peak controller. So first we will create a new project. Next, and define what type of controller we are going to use. And for this experiment, we will use the PIC 16F18875. Then click next. So we will choose the ECE8 compiler for this project. And then we will name this project as experiment 7. Then finish. So now, uh, we created a new project named experiment 7. So and the folders are already loaded. Now we will proceed to our MCC by clicking this icon. So now it is loading. So for this MCC, we will click save. So it does not load again. So we will try one more time. Now it is already loaded. Click save. And there we go. We are here now in our uh, MC. We are now here in our MCC. So now we will add our peripherals. So for this experiment, we will go to peripherals, or we just simply click this tab, the available resources. Then we will look for the timer 2, which is here. Then click the plus sign, and and we will set up this timer 2. So for this one, uh, we will see that we will enable the timer. So we will uh, check this one. So since it's by default, it's already checked. So we don't need to edit it. Now we will set our prescaler. So for this one, we will set our prescaler to 1:1. So for that, as we can see by default, it it has the prescaler of 1:1. And for our postscaler, we should select 1:16. So here in our postscaler, we will look to 1:16. So here. So now our postscaler is set to 1:16. So now we will set our timer period. So our timer period will be set on 16.384 milliseconds. So now we can see that the calculated period is 6 is 1.024 milliseconds. But it's not yet done. We will set our clock source to frequency oscillator over 4. So as we can see, the actual period became 16.384 milliseconds as the same we set on our timer period. So our uh, timer 2 is already set. So we will proceed to adding the PWM6. So this experiment is covered the pulse width modulation or PWM signals. So we will proceed to available resources again, and we will look to PWM6, which is here. So we will click the add sign, and now the PWM6 is already added. So as we can see, the enable PWM box is already checked, and we will select the timer 2 since we use timer 2 as our timer in this setup, and then we will set our duty cycle to 50%. So as we can see, uh, our duty cycle is 50 uh, percent by default. So now uh, everything is already set. So now we can proceed to uh, we can proceed to the code to setting our output part. So now we will proceed to our pin manager or the pin module, rather to the pin manager grid view. So as we can see, we will change the package on what we are currently using, and now we will set our PWM6 out, and we will set it in port A4, so which is here. So now it is set to PWM6 out in pin 6. So now we will proceed to our pin module uh, to rename uh, it. But so we will uncheck the analog, and there. So we will rename it to D2 underscore LED, but we will change it again here. So there. So now before proceeding to rename our clicking the PWM6 out, we should click the GPIO to rename the pin, and then we will click the PW6 out again to save it. So now everything is set for our pin module. For our system module, uh, we will stick here for by default. So it's already set in high frequency internal oscillator with an internal clock of 4 megahertz and a clock divider of 4. And the low voltage enable programming is enabled. So now everything is set. We will generate this code. So we will click generate. So as we can see, our our configuration is saved. So now we will proceed to the coding part. So we will go to project and look for our source files to the main.c. There. So first we will, so now we are here in main.c. So first we will initialize our the PWM signal. So, so PWM6 underscore initialize. Or we can simply look if there is a similar code in our pwm6.c file. So there, we can see our code there. So we will create a loop. So we will create a for loop in our main.c. So we will transfer it first. So let's type our code first. So this is our code. So it means that we define the variable duty with value of 1, and if duty is less than 512, duty the current value of duty will increment by 10. So now uh, we will proceed to the inside part of the for loop. And there we go. So we created another for loop inside with the integer named delay. So if the delay is less than 500, we will the delay will increase by an increment of 1. So this function can be seen again here, which is BMW6 uh, low duty value. So it is the same on our uh, in the inside code of our uh, main.c. So now the code is already set and we can compile it now by clicking the hammer icon or the build main project. So as we can see, our build is successful and it's ready to upload it in our IC. So to upload it, we should able we should connect our picket with IC connected. So to load the program, we will click the MPLAB IPE, which is this one. So as we can see, it is loading. So there you go. This is the MPLAB IPE. So first, we will go to settings and advanced mode. Then type in the password is microchip. Then log in. So we will set first our voltage options from this one, power target from picket 3, and we will set the voltage level to 3.125. So now we will back to operate and click connect to connect our picket 3 with our IC. When this dialog box appear, just click OK. So as we can see, there is an error. So we will try to lower the voltage level to 3 and we'll try to connect it again. And now as we can see, uh, the ticket 3 is already connected to our computer. So we will upload the code by selecting the hex file from experiment 7. Experiment 7, this default. And here's the hex file of the experiment 7. Then click open. And as we can see, the hex file uh, loaded successfully. So it is ready to the hex file is ready to program our IC. So we will click program to program our IC or to program the device. As we can see, it is programming and then As we can see, programming is complete. So now we will test how this program works in in our in a real life circuit, or how does the uh, program do with our LED. Now the code is already uploaded, so we will connect the ground of the LED or the anode to the ground of the power source, then a 220 ohm resistor to its cathode, and then the other end of the resistor is connected to pin 6. Then the pin 11 is connected to positive 5 volts, and the black wire, which is the in connected to pin 12, is connected to the ground. So when we power this circuit, as we can see, the brightness of LED gradually increases. And as we can see, uh, it is looping all over again. So after a first uh, rise rise of the uh, pulse, it will increase its brightness until it reaches the value of 512, as we seen in the code. So the L as we can also see that the LED gradually brightened up as uh, run over time, and it repeats itself again and again. So hope you like this video, and see you again next time.